Hey everybody, welcome back to my channel. So in this video, I'm going to show you different Python programs to convert decimal number to binary number. So I'll first start with the built-in function. So in Python, we have bin function. So bin function can be used to convert a decimal number to binary number. In the next approach, I'm going to use string format method. And in third approach, I'll use a while loop to convert a decimal number to binary number. And in fourth approach, I'll use recursion concept to achieve the same result. Let's open the PyCharm IDE and start implementing the programs. So I have opened the PyCharm IDE. So I'm going to implement the logic using a bin method. So if equal to I'm going to read the number input of enter some number. Now I'm going to call bin method. Print bin of. So let me run this program. So I'm going to enter 5 here. See, we got the equivalent binary number. Output of the bin method is a binary string. So if I want to remove 0 and b, I can just print the value starting from index 2. So I'm going to print the value from index 2. So let me run this program. I'm going to give some different method. Sorry, 0 to end of the string. So this will work. 17. Yeah, we got the binary number which is equivalent to 17 in a decimal form. Now I'm going to use the second approach using string format method. So I'm going to write the print statement to print the binary equivalent of decimal number. Print binary form of is. I'm going to convert decimal to binary. So I'm using B here. If you want to convert decimal to octal, you can use O instead of B. So let me run this program. Give 17 here. So we got the equivalent binary number for 17, that is 10001. So this is how we can get equivalent binary numbers using string format method. Now let's see the third approach using loops. So in the third approach, I'm going to use the while loop. As a first step, I'm going to divide the number with the 2. So the quotient obtained from the division will be used for the next iteration. And the remainder obtained from the division operation will be used to form the binary number. Remember, the remainder should be used in a reverse order to make the correct binary number. Now we'll implement all these steps in a program. I'm going to implement all those steps in a separate function, and the function name would be d to b of n. Let me make a function call here. So d to b of n, and I'm going to implement the function definition here, def d to b of n. So let me implement all the steps quickly here. While n greater than or equal to n1. So I'm going to get the quotient first. And I'm going to use the quotient for next iteration. Finally, I'm going to so let me run this program. Sorry, okay, colon should be there. I'm going to give it 17 here. Let me run. So I didn't get any result. Okay, so I have to print the function result here. Print result from loops. So let me run this program again. So 17. Sorry. 70. Enter. Yeah, we are getting the correct result now. So do you think our program giving expected result? Okay, let me run it for another number. I'm going to give 16 now. Now enter. See, our program is not giving the expected result. Why? Because see, I have already mentioned we should use a reminder in a reverse order to form a correct binary number. But here we have not reversed the reminder. So I'm going to reverse it using the negative index. Now let me run this program. So now we got the correct result. So this is how you can convert a decimal to binary number using loops. So now let's see the recursion concepts. Let's see how can we convert a decimal to binary number using recursion concept. So before we start the actual implementation, I want to share a few details about the recursion. The first point is, what is recursion? Recursion is a process of defining something in terms of itself. Suppose if you are implementing a recursive function means we make a same function called recursively. And the second point is every recursive function should have a base condition to stop the recursive function calls. Otherwise, the recursive function call should go in an infinite loop. And in Python, by default, we have a depth of recursion as 1000. And if the depth goes beyond this limit, Python interpreter writes recursion error. Now let's see the implementation. So I'm going to implement the process in a separate function. So function name would be D to B. Okay. So I'm going to add the definition here next to this function. Or of n. Now if n greater than or equal to 1, call the function, let's call the same function. Now the reminder. So let me run this program. Sorry. I'm going to give 17 here. So we got the same result. See here, we are calling the same function recursively until it reaches the base condition. So once the base condition is reached, the recursive call will stop and it will start printing the remainder in reverse order. Let me test it for another number. I'm going to test for 16 now. So let me give 16 here. So all the four approaches return the same result. Now I want to count the number of ones and zeros in the binary form of a decimal number. How to do that? So let me run this program. So I'm going to get the binary number for 17. So here number of ones is 2 and number of zeros are 3. So I want to print that count. How to do that? I'm going to use the count method available in the list container. So you can take any result. I'm going to consider the first result. So here I'm going to use the count of 1. Zeros. So let me run this program and see. So we should get number of ones as 2 and number of zeros as 3, right? 17. We got the result. Number of ones. First one is number of ones as 2 and number of zeros is 3. So these are the different approaches to convert a decimal to binary number. Please share your approach in comment section. So that's all with this video. Hope you like my video. If you did, please subscribe to my channel. Thank you.